Hi and welcome back. In this section we're looking at errors in Python. Python has got a long history with errors, and errors are really useful. And especially the way they're used in Python, as we're going to see throughout this section, makes errors powerful and they make your code very readable. So in this section, we're going to look at errors, how you can use them, how you can create them, how you can deal with them. At the start, nobody likes errors. Let's say we've got something like this line here. Print my variable. Now notice how I've not created my variable before, and this editor already shows me a small cross sign there that says undefined variable, my variable. But let's say we didn't have that hint there. Python hasn't ran yet, so this code is perfectly reasonable in terms of its syntax. We're printing some variable that Python doesn't know whether it exists or not until the point that it runs. So what will happen when we run this? What type of error will we get? Well, we will get a name error. As you can see up here, we get a traceback. We're going to look at exactly what those are. And then it tells us in file Python in line 1. And at the end it says a name error, and then it gives you a small description of the error. The name my variable is not defined. It's great to receive this error, as opposed to some other error, because once you know what it means, you can easily find the source of the problem. You can say, okay, my variable is not defined, so I must have used my variable somewhere, and it wasn't defined when I used it, and it tells you where that problem was, which is line 1, so all you have to do is go to line 1, find my variable and say, okay, why does it not exist at this point? And of course the reason is because we've not defined it above, and we can do that, equals 1, 2, 3, and then we can rerun this, and now this all works. It would be much worse if instead of a name error with a nice description, you just got an arbitrary, error. I'm running this to get the error again, and notice how it tells you where it is, and the name of the error and a description. If you didn't get any of this, it would be hours. It would take you hours or possibly days to find a simple error like this one in a large application. Remember, large applications, commercial applications, have tens of thousands or hundreds of thousands of lines of code. So if you got something that said, error, an error has occurred, and that's all the info it gave you, you would struggle. So the name of the error, name error, is really useful, but even more useful is the traceback. This is also called a stack trace in many languages. Traceback is stack trace, more or less the same thing. And what it tells you is where the error happened. And because we're running this file directly, it says it happened in this file. Now, this editor is an online editor, so we don't actually have a file, but it seems that the file is called Python or something like that. It tells you where it happened and so forth. So this traceback is a pretty simple traceback that has one line, and then it tells you where your error happened. Let's look at a slightly more complex traceback, which has more than a single line, and I'll explain what's happening in a larger traceback. It's really important for you to be able to read these tracebacks to understand what they mean so that you can solve your own errors. Here we've got a slightly more complex traceback. This time the traceback has 4 different lines. Now it's really important that at the very bottom of the traceback you're still getting the same thing that you got in the previous traceback. You've got the name, which is, in this case, it's a type error. And then you've got a small description, and it says list indices must be integers or slices, not string. And then as you go up, it gives you information of where the error happened. Now, we're going to talk about the stack trace right now, so let's give you a quick description on what is going on. So, at the very bottom, it gives you the error that was raised and a description, as we've just seen. In this case, it's a type error. Then it gives you what line of your code raised the errors. That's the very next line above the type error. In this case, the line that gave us an error was print, and then a formatted string that says name, and in curly brackets, movie's name. So this is the line of our code that gave us the error. Then it also tells us what function that line is in. That's just the line above. It says file, users, JSLVTR, Dropbox to Cloud, courses, complete Python course, section 3, milestone 1, app.py. It says line 40, and at the very end it says in show movie details. So this is the function that the error happened in, the show movie details function. Now, the line above is where that function was called. So this function, show movie details, was called as show movie details with movie as an argument. And the line directly above tells you in which function that function call happened. That's in the show movies function. The show movies function was called inside the menu function, and the menu function was called directly in the module, which is the file that we executed. So it tells you where your error happened, what function that was in, what function that was in, what function that was in, and so forth until you reach the file that you executed. So this is the code that raised that error. Now, we've got add movie, show movies, and then at the bottom, show movie details. I'm sure you remember this code. We wrote this for the first milestone project. And what we've got is an add movie. We are appending to our movies list, presumably, a dictionary that has name, director, and year. In the show movies function, we're taking a movie list, we're iterating over it, and for each movie, we're showing the movie details. Inside show movie details, that takes one parameter, which is called movie, and then it's printing 3 sets of details. Now, do you notice anything weird inside show movie details? Well, I noticed something which is there, and that's that the name is now inside curly braces movie's name, whereas the other 2 print statements are movie director and movie year. Notice how the first one has movies there. So what's happening here is that we're trying to access this name key of a dictionary, but what we're accessing it in is the movies list. So then it tells you you cannot use this key thing to access an item inside a list. You must only do that when the thing you're accessing in is a dictionary. So if that was movie, then we could access the name key of it. Because it's movies, it's a list, we cannot access the name key of it. Movies, by the way, was defined at the top of the file as a list. That's why movies is a list. And the movie argument parameter there is a dictionary that was passed in from the show movies function. So it told us, the stack trace told us that the error happened on this print statement inside the show movie details function, and the show movie details function was called inside the show movies function, which is exactly what you can see there. The show movies function was called from within the menu function, which you don't see in this code, but it was slightly above. And the menu function was called at the file level. So how do you deal with these errors? What do you do when you encounter one of these errors? And a lot of my students encounter errors, and the first thing they do, which is a perfectly reasonable thing to do, by the way, is they go and ask in the course Q&A and they say, look, I've got this error. Help me. Now, I'm happy to help you, but if the first thing you do is go and ask me to solve your problem, which I'm happy to do because that's what I'm here for, your learning is going to be slightly impaired. So here's my recommendation for when you get an error, what to do. The first thing to do that a lot of people miss is you have to look at your code. You have to look at the line that the error happened in and see if you notice anything strange with the surrounding lines. For example, in that function there, we were using the wrong variable. I know it's a single letter of a difference, but for Python that is a world of a difference. So look at the code carefully, and it's going to take some time for you to really start spotting those brackets or an S that's missing or not there, or small character differences at the blink of an eye. It's going to take some time for you to get accustomed to that, but you will get there. The next thing to do is, if you can't spot anything by just looking at the code, just copy the error and the message, just the very last line, and put it into Google and see if something comes up in Stack Overflow. Normally, there's always somebody that's asked, what does this error mean? And if you put in like a name error, variable blah 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 doesn't exist into Google, you'll get somebody that's asked, I don't know what this means, and then somebody that's replied, this means your variable's not defined. So it's always helpful to put things into Google and see what comes up. Maybe there'll be something helpful there. Now, if neither of these help, you have to start taking a more methodical approach to identifying the error. This is look at the code again, but this time much more slowly and run through it as if you were a computer. That means start at the very top of your code. Think, what data am I giving the computer in this line? Then move over to the next line and think, what data am I giving it in this line? And then into the next line and so forth. Mimic what the computer is doing exactly in every function. We're going to get a lot more experts in doing this over the next few sections. But as you do this, do you notice anything that could potentially be a source of an error? But remember, the error may not be in the line, or rather the error source may not be in the line that raised the error, but rather in a different line that maybe set the variable to the wrong value or something like that. If this doesn't help, run only some parts of the code. For example, try only running the showMovieDetails function with a dictionary as an argument. See if that works. If that works, try running the function that calls that function with some arguments. And then try running the function that calls that function with some arguments. As you incrementally run your code, eventually you'll reach a step where the error will happen. And you'll say, okay, the error must happen some point between these two function calls. And finally, if this doesn't work either, use a debugger. We're going to learn how to in the next couple of videos. Pycharm has an excellent debugger, and we're going to really be using that. And that debugger helps you step through your code and identify what variables are. It lets you sort of stop at a certain point in your code and inspect the current status of your program and so forth. It's really useful. And of course, at any point, I know this is quite tricky to go through all of these steps without despair. So at any point, ask questions in the course Q&A. We're here to help, so make use of that. Now, if you ask a question in the course Q&A, which again you should do if you're stuck, make sure that you give us all the information that you've already gathered through your search for fixing this error. That way, we don't have to then start at the top and do the same thing again. So if you tell us, I've looked at my code and I can't spot anything, then I've gone into Google and found that this error means that. And here's my code, by the way, and here's the data that I'm giving it. Now we can really quickly see, okay, you've given it this data, that all looks correct, this error means that. We can then piece the pieces of the puzzle together and find an answer much quicker. So when you ask a question in the course Q&A, give us all the information you can. And then the answer will come really quickly. We aim to have all your answers within 24 hours, but of course that's only possible if we don't have a back and forth between me and you trying to find out what the source of the problem could be. So that's it for this video. This is an intro to errors. Really, errors in Python, but also in programming as a whole. This is something you should be doing as you program in any programming language. So that's it for this video. I'll see you on the next one. Hi and welcome back. In this video, we're going to talk about errors in Python. And we're going to talk about quite a few of them. I just want to tell you something about these built-in errors, the errors that come with Python, so that when they appear in your programs, you'll know exactly what they mean, and you don't have to, waste time trying to find out what they are and how they happened. So we're going to talk about a few errors. We're going to talk about the index error and what it means, a key error, and name error. These types of error happened when you accessed something that didn't exist or in the wrong way. We're going to look at attribute error, which is fairly related. And then we'll look at not implemented error. This is an error that you can use. That can be really handy. We're going to look at runtime error, quite a generic error. Then we're going to look at also syntax error. This happens when you mess up writing Python code. You don't write proper Python. We're going to look at indentation error and tab error. And these happen when you mess up with the spaces or tabs or when you mix them together. We're going to look at type error and value error. And these happen when you give the wrong values or values of the wrong type to some built-in functions. Then we're going to look at import error and when that happens. And we're also going to briefly talk about deprecation warning and how you can use that. So the index error. The index error happens when you do something like this. The first 3 lines, by the way, are just the Python introduction type thing when you run Python on your console. I'll teach you how to do that in a couple of sections' time. Basically, we've defined friends as Rolf and Anne, and then we've accessed friends 2. But of course, friends 2 doesn't exist because friends only has 2 things, 0 and 1. When you access friends 2, that's an index error, because you accessed an index that didn't exist. In this case, it tells you that the list index was out of range. You're trying to access 2, but you only go up to 1. And this is a type of index error. Notice how the traceback tells you where the file, the line, and the module or function that you ran it in. And in this case, because I'm running Python in interpreter mode, that means you're just running Python interactively. It executes as soon as you type, so the file is just the thing I'm typing. That's what this file is called. Line is number 1 because, again, every line is number 1 in interpreter mode. And the module is just the module I'm running with. And that just means, when it says in module, that just means you are running the line directly. You're not going through any functions. So this is an index error. It happens when you access an index that didn't exist or an index that is otherwise incorrect. Then we've got key error. And this is fairly similar to the one we saw earlier. But now we have the proper code, movie name, movie director, and movie release. However, it should be year. And remember, in our milestone 1, we used the year key, and let's assume that we've used the year key for this bit of code as well. What we'll get then is this nice traceback. Again, what we've got now is a key error, and the description of this key error is pretty terrible. I don't like this description because it just says the key that you misused. So it says key error, release. Not terribly helpful, but now you know that you've used the release key at some point where you shouldn't have. And then, if the traceback is good, it'll give you which line that error happened. You've used it here in movie release. And then again it says, and this line was inside show movie details. Show movie details was executed as show movie details with movie inside it, and that happened inside show movies. That was executed inside the menu, and the menu was executed inside the module, or the file that you executed. Notice how all of these things are inside a file called app.py, because that's what our file was called in milestone 1. So the key error happens when you use a key incorrectly, or otherwise the key doesn't exist, but movie is a dictionary. Okay, so we've got movie being a dictionary, and then we accessed the incorrect key. If movie was a list, remember from the last video, we would get a different type of error. We also have name error. And the name error happens, as we saw earlier in the last video, when the variable is not defined. So here I've just launched Python and I said print hello, the variable hello, but of course hello is not defined, so I get a name error that says name hello is not defined. Of course, print of the string hello would still work, because the string hello is just a set of characters and numbers, or symbols, and Python doesn't evaluate it to a variable at all. So that would work, but printing the variable hello doesn't work. This is actually a really common error for my students, where they forget to, or you guys forget to, put the quotation marks around the string. Happens to everybody, and just remember, if you get a name error for something that is in a print, just check whether it needs quotation marks around it. That's a fairly popular thing, so just keep your eyes out. Let's also look at attribute error. Attribute error is pretty popular when you're starting to deal with objects. In this code here, we've got my friends list, which has 3 strings, Rolf, Jose, and Charlie. And then we've got some friends that are nearby, Rolf and Anna. And notice these 2 are lists, and then I'm doing friends.intersection of friends nearby. Intersection is something we can do with sets. If you recall, we looked at this earlier on in the course. It is not something you can do with lists. So then you get an attribute error. The list object has no attribute intersection. You can't do intersection because a list doesn't know what it is. So this is a nicer error message. It tells you what object you try to use, in this case a list object, and it tells you what you try to do that you cannot do. In this case, use the intersection attribute. Okay. This is a pretty nice error. When you get it, you see, okay, I messed up, I used the wrong thing there. We've got not implemented error. And this is an error that you won't be seeing very often, but it's an error you can actually use. And here's how you can use it. We've got a class that has an init method, a constructor, and it takes in a username and a password, and then it sets them, and then it's got a login method. But we've not worked on the login method yet, so it doesn't work yet. Instead of returning none or doing nothing, we can instead raise a not implemented error. And this is the syntax for raising an error. We're going to look at this in more detail in the next couple of videos. And then inside the brackets, you can put a small description saying something like, this feature has not been implemented yet. What's going to happen is when somebody calls this method, they're going to get an error. And it's going to say, not implemented error, this feature has not been implemented yet. And then it's going to say, when you called user.login. So it's a pretty nice error to raise when you've not yet gotten round to implement something. A runtime error. Runtime error is a pretty generic error, and it's not terribly clear when it happens. I've seen it a couple of times, but it's not an error you'll be seeing very often at all. This is essentially a base error, a base class, and other errors inherit from this one. Other errors extend this one to be runtime errors. A runtime error is just an error that happens when you're running your program, so that's basically anything. We've got syntax error. Syntax error is when we mess up on Python. So here we've got somebody messing up in defining their class user. Can you spot the missing thing? For me, this is like a big blank where something should be. But of course, for you, it may not be so obvious for now. And as you get more familiar with Python, as you program more and you encounter more of these errors, this is going to start becoming a bigger and bigger and bigger missing thing, which is the colon. The colon's missing at the end of the class. This is illegal syntax because you've got class user and then it expects a colon afterwards, so you'll get a syntax error, that's saying illegal syntax. Then we've got indentation error, fairly related, also a problem with syntax in Python, and the error could arise from something like this. You define the function at2, x and y, you put a colon after, and remember, the block of the function has to be indented. It has to have at least 2 spaces in front, preferably 4 spaces, but this return x plus y doesn't have any spaces in front. So you'd get an indentation error, and it would say something like indentation block expected after function definition or something like that. So basically, you can do this if you want. You can indent and put pass, and that just means this function does nothing. And then you can put the return x plus y at the bottom. But of course, this would also be an error. Do you know which error it would be? I hope you got that. It would be a name error, because of course x and y would not be defined. They are only defined within the function. Remember the concept of scope. They do not live outside the function. So as soon as the function ends, x and y no longer exist. You're using them here outside the function, because the function body is only the indented block. So this will give you a name error. You're trying to use x and y, 2 things that are not defined. Then we've got a tab error. A tab error is a pretty frequent error when you switch between editors. So just be careful when you're switching between editors that this doesn't happen. Here we've got add to function, and then the indented body has been indented with 4 spaces. That's what that little square bracket means. And that square bracket on the bottom of the line. Space, 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 return x plus y. So there's 4 spaces there, totally legitimate Python syntax there. You can indent using 4 spaces, but then notice how the pow function has been defined using a tab character at the start instead of 4 spaces. And Python doesn't really like it when you mix and match indentation types. So I'm actually not sure if this would work. But certainly within a function, do not mix and match types. Try to not mix and match indentation types at all in any of your programs. Decide now whether you want to use tabs or spaces and stick to that, at least within a project. So again, these are spaces, these are tabs. Don't mix them. And by the way, let's go back to this, and I will quickly just mention the pow function, what it does, because I don't think we've encountered this syntax before. We've got 2 arguments, n and exp, and then it's returning n times exp. And times in Python just means to the power of. And so that's n raised to the exp. For example, 2 to the 3 is 8, and so forth. Pretty nifty syntax there in Python. I don't think we've encountered that, just wanted to mention it. Let's go over to a type error. The type error is pretty common, and a type error can happen when you do something like this. In the first line, we're adding 5 plus 5, and that gives us 10, as we would expect. In the second line, we're adding hi plus ha, and it's giving us hi ha, as you would expect, because it's concatenating the strings together. And then we're doing something that you should not do, which is add a string and a number, and an integer. Do not do that, for that will be a type error. You've given the plus function, which is a function, two types that it does not support. So both of these things should be the same type, and you've given it an int and a string, and it says unsupported operand types. By the way, the plus symbol is actually a function. It's a dunder function like len. We will look into that later on, at how you can use it. But the int and the string objects have the plus dunder function defined, and it says that you cannot add them two together. So then you get a type error. Notice that you get the type error because somebody defined the int and str classes as raising this type error when you pass in different types. It doesn't just happen magically. Somebody has actually written the code to give you this error when you do this. So just remember, there's no magic here. It's all programming. Somebody has written the code that raises this error. Let's move on to value error. Value error is also very common. It happens when you give built-in functions a value of the correct type, a value of the correct type potentially, but incorrect value. So here's an example. We are turning into an int a string, which is normally a fine thing to do, but the string cannot contain decimal places. If it does, it says, hey, you should really convert this into a float, and that's what you should do. So here we're calling the int function with 20.5 as a string, and it says value error, invalid literal for int with base 10, 20.5. 20.5 is not something you can give the int function. Normally, only built-in functions will raise a value error. If you want to raise value errors, I recommend that you create your own errors, which we're going to look at later on in this section. Finally, we've got import error. An import error is also really popular and is a big pain in the ass. And here's when it happens. You've got an import blog inside app.py, and then you've got blog.py, say that from app imports menu. Let's imagine you want to run the menu inside blog, or maybe app has some sort of variable you want to import or something. So what's happening here is that app is importing blog is importing app, and what happens when you import? Well, you go over to the file you imported and you run through it quickly, define the functions, execute any imports and so forth. And once that's done, you go back to the original file and you continue from right after the import. So importing blog actually runs blog.py. What happens when you run blog.py? Well, it has to go over to app.py and run that. The first line there is import blog, so it has to go back to blog and import app, and then it goes back to blog, and then so forth. This is a big ass circle, and what happens is, circular imports. This is what they're called, importing one file which imports the same file. You'll get a circular import. And this doesn't necessarily have to happen from between two files. You can have file A that imports file B, that imports file C, that imports file A. So you can have a circular import with many files, and it can be a bit of a hassle. So just be careful with your imports. You'll get an import error, and it will say something around the lines of circular import here. So be careful. If you get an import error, ask a question in the course Q&A. We'll be very happy to help you out. Finally, let's look at deprecation warning. A deprecation warning is, as it says there, a warning, not an error. However, Python treats it the same way. So if you produce one, if you raise one, your program will still crash. But it's meant to mean, hey, something wrong happened here. This thing that you tried to do is deprecated. And what does deprecated mean? Deprecated means that it is no longer the best way of doing something. There is now a better way of doing whatever it is you're trying to do. Let's look at this example code. We've got user class, and at the top we got from database import database. The user class has a constructor, and then it has two methods. A register method, which is an instance method, that writes to the database the username and password of the user. Then it also raises a deprecation warning, and it says, user register still works, but is deprecated. Then we've got a class method that is called register user, and that takes in a username and password, and writes to the database the username and password, and returns an object of type user. I like this second one better, that's why it's in this example. But nonetheless, it was just to show you that you can raise a deprecation warning in any of your methods to tell whomever uses it that, hey, this is no longer the accepted way of doing things. But, there is a but. Often you won't be raising any of these exceptions except possibly the deprecation warning, probably not even that one. You'll normally be raising not implemented error if you are sort of working on something. But you won't be raising many of these. You should create your own exceptions with even better names. And we will look at exactly what that means and what a better name is and how you can create your own exceptions. So let's look at that right now in the very next video. I'll see you there. Hi and welcome back. In this video we're looking at raising errors in Python. In the last lecture I showed you the syntax real quickly, but we're just going to go over it again in this video and give you a couple examples so that you know in which scenarios you should be raising errors. And also I'm going to introduce a new piece of Python syntax that I think is pretty cool. So let's right click our project that I've just created in Pycharm and create a new Python file. And again I'm going to call it app.py. This is a pretty popular name for your first or your most important file in Python that you're going to run. So you can right click it and run it. Normally this file will be called app.py or run.py. It's just a name for your main most important file. Let's say we have a code that is for a garage and it stores cars and you can add cars to it. So let's define a class garage that has an init method, and it defines self.cars to be equal to an empty list. By the way, notice how in an attempt to reduce any indentation or tab errors, I have told Pycharm to show me any hidden characters or invisible characters. You've got these small, tiny dots that you can barely see without being in a video. You can certainly not see them very well on video, but you've also got these lines here. So you've got these dots that are very small. I'm going to zoom in the video just so you can see it. And you've got this line here. The line tells you where an indentation level begins, or where it is maintained. The dots show you the spaces. So you know these are not tabs, they're spaces. Okay, so if we were to add another line here, notice how now we've got a three line long grey line here that tells us that the indentation is maintained for all of this. Okay, so this garage has an init method. It has a len method, and that returns len of self.cars. And also it's got an add car method that takes in a car that we're going to add as an argument. However, we've not yet had the chance of working on this too much, so what we're going to do is we're going to print this method is a work in progress. This is obviously not the right way to go about it, as you know now. But then let's say that we are using this garage, so we're going to say Ford garage is garage, and then Ford.addCar, Fiesta, and then we want to print the len of Ford. Now, this method here is going to print out something out of the screen. But if we were not really paying attention, if we were, for example, saving this thing here to a file or to a database, we may not realize that this is printing something out. We would just see that this is 0 every time. Let's run our app. And as you can see here, it says this method is a work in progress, first of all, and then it just says 0. No matter how many cars we add, all we're going to see is this method is a work in progress over and over again, And if we were saving this length to a database or to a file or somewhere, it would always be 0. If you run it, then you may wonder, hey, what's going on here? And then you're going to have to actually run the program manually, like so in Pycharm, to see the printouts. And then you'd see, okay, this method, this code isn't working yet. So instead, of course, we can raise an error. We can raise, and all you do is raise, and then type a not implemented error. And then you got brackets, so you're creating a new not implemented error instance. This is a class. You're creating a new object of type not implemented error, and you're raising that. Inside the brackets, you can put a small message. We're going to say we can't add cars to the garage yet. Now when you run the app, which I'm going to do by pressing on the top right here, you get your nice trace back. Then it says, not implemented error. We can't add cars to the garage yet. Then it tells you where that error happened. Raise not implemented error. Here, we did it manually. It says line 9 in add car. So that's line 9 of our code inside the add car function. Now, where was this function called? Where did this function originally happen? On line 13 here. And for.addCar Fiesta. So as you can see, the error happened here. Inside this function was called here. So it tells you all the functions and parts of your file where this error has gone through, from being raised up until it reached the file level. So that's two places right now. So this is much better, because now when we run the program, it's going to crash. We're not going to save anything to the database, and we're going to see, okay, it crashed, let's investigate. We would see that a not implemented error was raised, and that's all good. So this is how you raise an error. You use the keyword, then you create a new object. You can put something inside the brackets, which will be the message. Let's say we add another class. That is going to be a class of type car. And that's going to take a make and a model as parameters. And then it's also going to have a wrapper function, of course, because you always want these things. And it's going to return a car with self.make and self.model, like so. So this is just a representation of a car. Remember the wrapper dunder function. You can print out the car object, and it's going to print something that looks like this. Okay. Now, the add car function here should only accept the parameter being a car object. So how do you do that? Well, pretty straightforward actually. There is a built-in function in Python called isInstance. isInstance tells you whether the variable that you give it is an instance of the type that you give it. So this is the variable, car. This is the type, which is the class, car with a capital C. So if not isInstance, so if car is not an instance of car, we're going to raise a type error. And we're going to say, try to add a car class name to the garage, but you can only add car objects. So there's a bit of a longer message there. And all I've done is formatted a string and said car.class.name. That's the name of the class of the variable. So if this was a string, this would print out str. If this was a class, if this was a car, it would print out car. And this is just a nice bit of a construct that you can access for essentially any variable. This gives you the class of the variable, and this gives you the name of the class. So we try to add that to the garage, but you can only add car objects. And then, of course, we're not going to raise a not implemented error. And now here we can say self.cars.append car. And you may wonder, well, why do you not put this in an else? You don't have to. If the car is not an instance of the car class, we're going to raise the error, and that's going to crash our program. We are never going to reach this line if that happens. If, however, it is an instance, it's not going to go in here, and it's just going to go here. So you don't need the else for anything, because there are only two paths. One where this doesn't run because you raise the error, and the other one where this runs, and that's where you want it to run. So that's sufficient. So once again, let's try to add this string car. And notice how now we get a nice traceback here that says, try to add an str to the garage, but you can only add car objects. I think that's a pretty nice error message. So what can you do? Well, you can create a new car object. Let's say car, this is going to be a Ford Fiesta, and then you're going to add that car, which is a car object, into the add car function. Again, the value of the car variable is a car object, and that's what you are teleporting over to this car variable. Okay, so the value of the car variable is now being assigned to this car variable here, and then you're going to use that inside here. So now we can run it, and it all works. We can print the len of Ford, and you'll see that 1 gets printed out, which is pretty nice. This is raising errors in Python. It's really straightforward. All you have to do is, when you want an error to happen, raise it, create an object of it. You remember the brackets, and inside the brackets, if you want, it's totally optional, you can put a nice message for when the error gets raised. The person who's writing the code knows what happened. Errors are most useful for developers. Of course, if your users, if somebody was downloading this code over the internet and saying, I'm going to run my garage, of course, it's a bit basic for that, but if somebody was downloading your code and using it, they encountering a type error may not be terribly useful for them because it doesn't tell them anything. They're not developers. So errors are most useful for developers. When you are writing code or when somebody else is helping you write code or working on a team, having nice errors can be really helpful, because then when you make a mistake or you do something incorrectly, you'll quickly get an error and you'll be able to fix it. If you don't get errors and instead you print things out like we did earlier on, you may never find out that this is not working until you see that the program doesn't do what you were expecting. So raise errors, use them, and they'll be your best friend in no time. So that's it for this video, raising errors in Python. I'll see you on the next one. Hi and welcome back. In this video we're talking about creating our own errors in Python. Let's go over to our errors project and I'm going to create a new file. I'm going to call this errors.py, and we've got now ourselves a blank file. We've looked at how we can raise errors, but we've only used the built-in errors. That's, for example, raise type error. We've got this type and we've created a new object of it, and that's what we raise. Now, we know how to create a class that extends everything from another class, essentially a copy. How to create a class that is essentially a copy of another class by using inheritance. If we had to create a custom error so that we can do my custom error, remember this is a class and it has to inherit from one of the built-in errors. You can pick any you want, for example, type error. Go ahead and pause the video and try to create a class that would inherit from a type error. How you may go about that. It's fairly straightforward, it'll just be a couple of lines. Okay, I hope you managed that. Very straightforward, but it can be a bit confusing when you encounter that you have to do something in a new scenario that you hadn't thought of before. Creating a class that extends a type error is just like creating a class that extends any other class. Class. My custom error, type error. And then of course we need the indented block, but we can type pass to just pass through and not do anything. Now we can raise my custom error because it essentially is a type error. It's just got a new name now. So we can raise it. Let's right-click errors.py and run it. And by the way, if you start getting accustomed to pressing the play button up here on the right, that's fine, but make sure to check what you are running, which is this thing here. And right now you're running app. So So if you press play, you're going to run app.py, not errors.py. So you may want to run errors. Now notice how you get my custom error thing here. But it doesn't have a message or anything like that. And what you then get is __main__ dot my custom error. Don't worry too much about the main part. We're going to look into exactly what it means in the next section. But just know that you've managed to now raise an error which is called my custom error. And of course, you can put in here some message. This is a pretty terrible message, but you can. Now, we've made this edit, and I'd also like to intersperse into here some Pycharm goodness. Now our run file has changed to errors.py. So we can press the play button up here on the right, or we can press the play button down here on the left. And that's fine. And that's going to rerun that file. And now you can see that you get a nice description beside your name of the error. This is how you can create your custom errors. Now, of course, you can have a custom error that takes in some more data other than just a message. And this is part of the power of these custom errors. That, for example, say you want your custom error to include an error code. These things are fairly popular. For example, if you've ever got a printer, you'll know that they give you error codes all over the place. And sometimes it can be useful to have error codes in your messages. Now, an option is, of course, to have something like error code 500, ouch, an error happened. But you don't know that this error code is 500 from a program point of view, because of course this is a string, it's just some letters and numbers and symbols, and Python can't interpret it. If you then wanted to check whether your error has a code 500 or not, it would not be so easy. So instead, the best thing to do is to have two arguments, the message, and then the code, for example, 500. But in order to do that, we have to define a new constructor in my custom error. So let's do that. And what we want to do is call the superclass constructor with, message code. Call the superclass constructor with the message as an argument. We'll call the superclass init method with the message as an argument, and then set the code to be a property of my custom errors object. So pause the video and give that a go. I hope you managed. In order to call the init method of the superclass, all we do is init message. So now we are passing the message parameter to the init method of the superclass, which is type error. And we can also do self.code equals code, like that. Okay. Now we have this here, and we can play the errors file again. But notice how we don't get any extra information in the message. We've got ouch, an error happened, and we don't know that it's an error code 500. All we've got is this 500 code on the line where we actually raise the error, because this is the line where we raise the error, and we've typed 500 in there. So what can we do? Well, we could put the error code in here again, but of course that's not great, because if you then go and change this when you say 400, then you also have to go here and change the string. So not fantastic. We don't want to do that. What can we do instead in order to include this error code inside the message? I hope you managed that. All you have to do is, when I show you if you didn't quite manage, is fairly obvious, but of course you have to think in this way. You just want to create a new string that says error code message. That's it. We're just creating a new string which will now replace the message we got in by this other string that contains the error code as well. And in order to begin thinking this way, that takes time, that you can essentially do anything you want. All that's happening in these method calls, calling the init method and raising things like that, data is moving from one place to another. You've got this string, And that string is now being assigned to message. Then that message was going to go over to this init method, where it was going to be assigned to something else. Someplace in Python's code, that message was going to be used in order to print it out to the console. But that is just a string. If you can put a string in there, you can put any string value you want, which means you can modify it here and just pass in slightly different data. That's totally fine. Not a problem there at all. All we're doing is modifying some data, passing it over to the next level, which is the type error. And at any level of our program, at any line we want, we can change the data that we're passing around. And that's really what programming is all about. Passing data, passing messages from one place to another. Anyway, now that we've looked at how to create your own custom errors, I also wanted to give you some more Python goodness, which is the docstring. We've not looked at docstrings yet, but I'm about to tell you about them. Under the class, and not inside the init method, you can type a multi-line string. And if you remember correctly, the multi-line strings are those that have 3 quotation marks at the start and 3 at the end. This is a multi-line string, which means you can, for example, down here, print a multi-line string that says, "Hello, how are you?" Like so. Of course, you cannot do that because you've raised an error there. But this is fine, you know? You can run this here, and what you get is a bunch of lines there with the indentation and everything else. If you do that, now you get 2 lines. Of course, this is a new line here, so you may want to do this instead. Now you get them all in a single line. This is a multi-line string. And multi-line strings are pretty useful when you have a very long string that you want to print out or otherwise use, but also when you have a multi-line string directly underneath a class or directly underneath a method or a function, you can actually type some stuff here that will be a docstring. That's some information about what the class does or where it's used or why it's used, so that other Python developers can look at it and understand what it does, and also it becomes a part of your code. And I'll show you exactly what that means in just a moment. So let's say we wanted to tell other developers that my custom error exception raised when a specific error code is needed, because this has a code here. And then we're going to rename my custom error to runtime error with code, for example. Not a very good name, but you know. So now what we can do is we can, whenever we're looking at this code, we'll quickly see, okay, this is an exception that's raised when a specific error code is needed. That's cool. And that helps us understand exactly what this is for. If you were to create an object of this type without raising it, just for the sake of example, you can do print error dot underscore underscore doc underscore underscore. And of course, we're gonna give it the arguments that it needs. So you can print the variable name, which is your object, dot underscore underscore doc underscore underscore, and that is going to give you the docstring that you wrote there. This is particularly useful when you are developing and you want to, look at what something is defined to be. Maybe not so useful when you're writing a program, but nonetheless, it's interesting that Python sees this thing here, which is just a string, as something that has particular meaning. And using docstrings, for example, in functions, particularly complex functions, and in classes to explain what they do, and you can also use them at the very top of your file as a module definition, or what this file is all about. You can do that as well. You can put a docstring up here. There are many tools that will read those docstrings and create a nice page explaining sort of what your classes do and what your methods do. This is for creating documentation, and it can be pretty useful. And that's really how the docstring came to be. It was people wanting to add some descriptions on what their classes and their methods do. So feel free to do that, particularly if you create any slightly more complex functions. As we'll see in the following sections, we're going to be actually merging all our Python knowledge together and creating some nicer projects. You can use docstrings in those cases just to explain what exactly these things are for when you come back to them weeks down the line, or when you're working with someone else and you want them to be able to understand exactly what happened more easily. Okay. And of course, you can have your docstring, just as an aside, you can have your docstring in a single line. This is a single line, multi-line docstring. This is also fine in case you want to save space. You can have the docstring in here, but the docstring must have these triple, double quotation marks. So these three. That's just a convention for docstrings. Okay. All right, that's it for this video. We talked about how to create our own errors by extending from a particular error. And if you don't want to extend from type error because your error is just not a type error, for example, you can just extend from exception. Sorry, not error. You can extend from exception, which is sort of the most base exception class that you should inherit from. Don't extend from base exception. That's not for us to use. Just extend from exception. And that's fine. Okay. That's it for this video again, and I'll see you on the very next one. Hi and welcome back. In this video we're talking about dealing with errors. One of Python's core tenets is ask for forgiveness, not for permission. Now, I know how well this works with friends and family. Not so well, but it works fantastically in Python. Let's have a look at this piece of code here. We've got our car class and our garage class. And previously we looked at how we can check that we make sure that the car is an instance of type car. But let's imagine that we did not do that. And instead we did something that's pretty normal for the majority of programming languages, which is to just, when you add a car, just add the car. That's what the method does. And then we would, of course, use them like so. Ford equals a new garage, and then Fiesta is a new car. And then, of course, Ford.addCar, Fiesta. This is the normal usage for these two classes. Now, normally, if we wanted to make sure that we're only adding car objects to the garage, we could, of course, do this. If is instance car, then do this, else print, your car was not a car. Your car was not a car. Or you could potentially raise an error here. Sorry, this should be Fiesta, not car. This is a pretty typical structure of calling a function, in this case, the addCar function. And before you call the function, you check whether that's something you can do. Can I call this function? Yes. Then call it. And if not, say an error happened. This is really popular structure in a lot of programming languages where you ask for permission first, and then instead of for forgiveness. So here you're asking for permission to run the function with the data you've got. If you get it, because this matches, then you add the car. Otherwise, you say your car was not a car. Python suggests that in many cases our code can be made more readable by asking for forgiveness instead. So doing something like this. Instead of that, doing something like this. Try to call function. This is not real Python code, by the way. If failed, do something. Say that an error happened. So you can see this is slightly more concise, because you don't have to check whether the function is okay to be called or not. Okay, so circling back to raising exceptions, we could go back to adding our isInstance here. If not isInstance car of car, then raise a type error. And I'm just going to copy the string back from my notes so I don't bore you typing it. So again, it's the same string as we had before. So Python suggests that this is better because now we only have to check whether the car is appropriate once inside the method, and everywhere else, we can just call it. We can just do Ford.addCar Fiesta. Of course, an exception might happen, an error might happen. And by the way, error and exception are pretty much the same thing, okay? I started with Java a long time ago, and they're called exceptions there. So an exception or an error might happen when you call this method. For example, if your car is not a car, it's a string. So what do? Well, we're going to try to run the code. We're going to try, and that's try with a colon. This must be indented because this is a block. And then we're going to have an except. So we're going to try to run this block of code, and if anything happens, an error gets raised by something inside this code, such as a type error, we're going to say print, your car was not a car. Okay. Now what's going to happen is, again, we're going to try to run this code, and then we're going to accept. And the only error we're going to catch, so if a type error happens, we're going to print this out. If a different type of error happens, like a value error, that will not be caught. So here, let's see what happens when we run app.py. Remember, make sure to right-click app.py and run it. Now we get nothing, because of course the car was a car object. Let's try adding a Fiesta here and run it again. Now we get this message saying your car was not a car. Cool. What happens if instead of a type error here, we raise a value error? Not the right error to raise, it should be a type error, but just for example, now we get this traceback. And that's because the only thing we caught was a type error in our accept. And what happens when that happens is that the error stops being raised up to the next level continuously, and instead it just dies here, and we get access to doing something when that error happens. It's really good to catch the errors on your user interface. In this case, this is our user interface, sort of. It doesn't have much of an interface. But so that, and you should catch them so that users don't ever see this. You don't want your users to see errors. However, you should not necessarily catch them when you are working on the code that users are not going to interact with directly. That way, if an error does happen anywhere in your code, your program is going to crash, and that's good while you are writing code. Once you share the program with your users, you don't want errors to be appearing, so you want to catch them, like so. Okay. So there are two benefits. One is that I think our code reads more nicely. We're going to do this. Oh, okay, if an error happened, we'll do that instead. We don't have to check whether we can run something. And the second thing is that our check is now here. So for example, if we wanted to add 2 cars before, we would have to have this if twice before we add each car. Now the if is in the add car function, and our code only needs this single line. So again, the syntax is this try except syntax. We try to do whatever is in the try block, and if an error happens, we jump to the except block. And we do so only for errors that match the one in the block, a type error. We can catch multiple errors by just adding another except block. Like so. Now, if there is a type error, this would run, and if there is a value error, that would run. This is particularly useful when you have multiple types of errors that could potentially be raised. Of course, here, it's unlikely that that's going to happen. Over the next few sections, we're going to make use of this try except syntax a lot. So, just something to keep in mind as we move forward. Try and except also have a final counterpart, which is called finally. The finally block runs every time. So you're going to try to run this code here. If an error happens, you're going to run whatever code is in the appropriate block for the error. And at the end, you're always going to run the finally block, whether or not an error happened. So here you could, for example, print the garage now has Len Ford cars, for example. So again, except blocks may or may not run, finally always runs. So again, if we run this now, we get something weird happened because we raised the value error up here, and then we print out the garage has now 0 cars. Notice how we don't see a stack trace because the error has been silenced by the fact that we caught it. So in the next video, we're going to look at how we can not silence it. And that can also be quite useful, especially when you're developing. I'll see you on the next video. Hi and welcome back. In this video, we're talking about re-raising errors and the onSuccess block. As you can see, I've written some code here. That's just because I didn't want to bore you going through writing all of this code, especially because it's only example code. This code is also available in the code lecture on GitHub, and that lecture is at the start of this section. So if you've not yet downloaded or had a look at the code for this section, you can go to the first lecture of the section and go to the GitHub link that's there, and you can see this code. The resource that's attached to this lecture contains an explanation for some reasonably related sample code as well, but it's not exactly the same thing. Just because the resource attached to this lecture has some explanations and it uses some pseudocode to explain some concepts, the code that I'm seeing here on my screen, the code that you're seeing on your screen, is on the GitHub. So feel free to download it and have a look if you want. So what we've got is a user class. Nothing new here. It's got an init method that takes in a name and a property engagement, a variable engagement, and then sets the name to be name and the engagement metrics to be the engagement property there. Then it's also got a dunder repr function that returns the user's name in a nicely formatted string. This user class is going to be used by this getUserScore function that takes in a user parameter. This is going to try to return whatever the perform calculation function gives us with the engagement metrics of the user passed in, and if it fails, it's going to print out incorrect values provided with a key error. Perform calculation takes in the user's engagement metrics as a parameter there, as an argument, and then returns the clicks property of that metrics multiplied by 5 and the hits multiplied by 2. So imagine this is a user that's visiting a website and we want to calculate, their score to see how engaged they are with our brand. If the clicks multiplied by 5 and the metrics, the hits multiplied by 2 gives us a particular value, we're going to say, this person is very engaged. We've also got down here another function called send engagement notification. And this would send them an email saying, thank you for being so engaged with our brand. Here's a coupon code for you to download or something. Of course, this doesn't actually send any emails right now, but we could do that and we'll look at sending emails later on in the course. Then at the very bottom, we're creating a user. Rolf is the name, and these are the engagement metrics. He's done 61 clicks and 100 hits. And then we're going to call the getUserScore function here for my user. So this is the sample code we've got. Not too much code, I hope. Fairly understandable, I hope. It can sometimes be handy to do something with an exception, handle it, like we do here. But then it can also be useful to not silence it, i.e. keep letting it bubble up and eventually crash your program, so you know that you've done something wrong at some point. For example, the exception here, key error, is caught, and if we were to mess up and create our users with a click key instead of clicks, this is going to fail with a key error because clicks won't be a key of our metrics dictionary that is down here. So let's run UserScore. Remember, right-click it and run it. And you'll see that we get incorrect values provided to our calculation function. And we get that because, of course, the key error was raised, and we then printed this out and nothing else happened. If we are not paying attention, we may miss that. Let's face it. If this is the only line of output in our program right now, but if this was a long program, there may be many lines of output, and you may miss that one amongst all the other ones. So the best thing to do, at least while you're developing, is to allow the errors to continue bubbling up and crash your program. When you're going to give your program to your users, make sure that your program doesn't crash too easily. And that may mean catching the error somewhere or not allowing it to continue bubbling up. The way we allow it to bubble up is we just type raise. And that has to be inside the accept block. So inside the accept block, we can raise, and what that does is that re-raises the error that got us into this block in the first place. So if we press play again, you'll see that now we get our traceback after we get our print. The traceback now says key error clicks. And that was used here in metrics clicks, multiplied by 5 and so forth. This was inside the perform calculation function, as you can see here. And this was called up here, as you can see in this line. This was inside the get user score function, as you can see here. And that was called here, which is down here, line 27. And that is in your module, which is your file that you're running. So that's the file that you're running. Okay, this is, again, the stack trace. You need to get good at understanding and following the stack trace. That's a really important skill. So the raise keyword here must go inside the accept block. Otherwise, you cannot use raise on its own. You have to give it the error you want to raise. But that's only if you use it outside the accept block. If you use it inside the accept block, you can just type raise and it will re-raise the error that got you here in the first place. Okay, now let's say that we want to send an engagement notification to this user if we've got some limit of clicks or something. Let's say that if the user's score is over 500, we want to send them a notification. We only want to send the notification, and by the way, I'm going to remove this raise thing here for now. We only want to send the notification if we didn't raise an error, of course. We only want to send the notification if the perform calculation succeeded and we got a correct score. So how may we do that? Well, we've seen the finally block. We could say send engagement notification to user. But the finally block runs no matter what. The try is going to run, the accept may or may not run, and the finally will run. So finally is always going to run after the try accept block no matter what, unless of course you re-raise the exception and your program crashes. If you do that, the finally won't run either. But let's imagine we don't want to re-raise the exception, but we want the engagement notification to send if our user does have the correct score. Well, we can use an else, actually. And that's a pretty bizarre thing to use here, because what it means is that we're going to try to run this thing here, and if there is no error, we are then going to go to the else. So this else is only going to run if an error does not happen, unlike the finally, which runs every time. Of course, it's telling us this code is unreachable, because if this code succeeds, we are returning, which means we're exiting the function, so this is never going to run. Either we will have this error, in which case this won't run, or we will have this return, in which case this won't run. So we just have to remove the return there. And if we did want to perform a calculation here and just return that value, and then we should do that, and then we should not use this construct. Instead, this should go down here. Right? So this function maybe should be renamed to something else other than get user score if we wanted to do this. Okay, maybe it should be email engaged users or user, something like that. Okay, so I just wanted to show you this construct because it's not a popular thing. Not a lot of Python developers know about it. And indeed, if you go on the internet and look at tutorials for try except in Python, I guarantee that almost none of them will mention this else. And it's not that used, but it's interesting to know about it just in case you want to run something only if an error doesn't occur, like send an email notification. We will be using this later on in the course. So that's it for this video. we've looked at the onSuccess block, that's this one here, because this happens when we succeed in our try except. And we've also looked at re-raising exceptions, which is very simple. Just put a raise inside the except block, and if an exception does happen, we will raise it again. So, by the way, I've changed the click back to clicks. So now we should be able to run this. And of course, I've also renamed the function. So let's make sure we're calling the right function. We should be able to run it. And, this one here. Sorry, I didn't change it. Now we see that the notification was sent to user Rolf, because we performed the calculation and then we send the engagement notification. And if we wanted, of course, to check that the user's score is correct, we could do something like user.score is that, and then if user.score is greater than 500, send the notification. Now, we've said user.score here is equal to something, but user.score was not defined in the init method. This is a bad practice. You should generally define all the properties in the init method, just so you know what exists. So you can define the score as 0 in here, and then this is not creating a new property. Although you can, it's not advised. And now this is just updating it, which is better. Now we can see that a notification was sent to the user Rolf because their score is greater than 500. Indeed, 61 times 5 plus 100 times 2 is 502, I think. I'm pretty sure. Let's not say that it is any number. It is greater than 500. That's what I know. So that's why we're sending the notification there. Anyway, that's it for this video. I won't keep you any longer. This was the try except else and how to re-raise exceptions as well. I'll see you on the next one. Hi and welcome back. In this video, I just wanted to go over the quiz you've just done. At least I hope you've tackled it. And guide you through some of the answers. And then also give you the code that I would use to avoid the problems that Ben and Dan had in this quiz. I'm just doing this for this quiz because it's a tricky one, and it's interesting, and it's a problem that you'll see happen over and over again. So let's start the quiz. We've got a quick question to warm us up first of all, and we get some background. Now, for this quiz, if you haven't done it yet, I'd encourage you to sort of take it seriously. Think as though you were one of these two developers and how you would implement this bit of code. So Ben and Dan are two novice software developers, and they are trying to build a function that asks a user for a number and calculate its power of 2. And here's the first version of their code. So we've got a function called power of 2, and the first thing it does is it asks the user for a number, multiplies it, powers it by 2, squares it rather, and then returns n squared. So what do we think? Will this work? My immediate thinking for this is, input gives you a string, so this is not going to work because a string to the power of 2 is going to break. So I'm going to say that the program will break in all cases, and that's the correct thinking. Of course, for me it's a bit easier because I've actually made the quiz, so I sort of know the answers. But I would expect you to be aware of the input function returning a string in all cases at this point. The second question starts getting a little bit trickier. So they've realized their error, and they have a second version where now they are putting the user input into a variable called user input, and then they're turning that into a float. So that's a decimal point number. Then they're going to square that float and return it. And it's pretty common for people to do something like this, even as professional software engineers. You've got your input, you're asking the user to enter a number, so of course they're going to enter a number, and you're going to turn that into a Python float, and then you're going to square that, and it's all going to be fine. But users don't always play nice. Sometimes, you'll ask them to enter a number, and they'll by accident, type out the number 10, or maybe they'll type something else by mistake entirely, or they won't understand what you want them to do. So now there are 3 options. It will work in all cases, and a lot of people will say, yes, it'll work in all cases, because the assumption is the user is going to enter a number, but that assumption is flawed. because the user may not. So it's yes and no. The program will work on some inputs, but break on other inputs. And that's correct. Then we've got version 3, and this code starts getting a little bit trickier. So after shipping their version 2 code, Ben and Dan had some serious complaints. This is a frequent thing. You will get complaints if your code is broken, if you have users using your code, of course. So now it becomes a little bit more contrived. Now we're getting the user input into a variable, and then we're initializing a try except finally block. Inside the try, we're trying to put the user input into a float and inside the variable n. Remember, n is defined inside the try block, so it doesn't exist anywhere else. If that fails with a value error, which means the user entered a string, we print your input was invalid. And finally, at the end, we square n and return that. But of course, n was defined in the try block. It's possible that if that failed with a value error, we don't have n. So n squared will be error because n is not defined. So in this case, they are trying out the code with 2 different inputs. This is good. You should try out your code with multiple inputs. And in the first case, he's going to enter 4, and in the second case, he's going to enter the string Dan. So for 4, it's going to work because the float of 4 is going to give you something. Then you're going to go and jump down here. But for Dan, you're going to get a value error, which means you're going to try to multiply something that doesn't exist. So you're going to get 16.0 and error as the solution. Now, for this version, we've got something a little bit different. Fairly similar in many regards. We've got the user input as a string, then we try to convert it into a float and put it into the variable n, and then as if an error happens, we print out the input was invalid and we say n is 0. So what is going to happen in this case? Well, the else block, now this has been replaced, replacing the finally block. The else block only runs if there was no error. We've seen that just recently in the last video. So if we run through the try block successfully, we will then multiply or square and return that. If we get an error, we're going to jump into the except block. N is going to be 0, but we're not going to run the else block and we're not going to return the square. So we're going to return none by default. In this case, the answer is 16.0 and none, because the first test case will return 16.0. The second one will return none because the function doesn't return anything if it doesn't succeed in the try. So that's the correct answer there. Then we've got a slightly more complicated version, and you may now be able to see how to fix this code. And you may be thinking, this code is now way too complicated. Why would anybody write this code? And you're right. If you know how to solve the problem, and you're coming at it with a pair of fresh eyes, you may never write something that looks like this. But if you have made a mistake, and then another one, and then another one, and suddenly there's a pressure for you to do it right, there's a pressure for users to be happy, there's a pressure for you to give this code to your users quickly, mistakes start to happen, and you start getting a narrow focus on the problem, and what you start thinking is, what do we add quickly to fix the problem? And you stop thinking about how do we restructure this code so that it solves the problem without any cruft or any useless code. So in this case, we're getting user input is the input of the user, then we try to turn it into a float. If we fail to do that, we print out that your input was invalid and we assign n to 0. If we succeed in getting n, we type out n squared is n to the power of 2, and then we finally return n squared. Of course, same problem as before. When we type 4, the try succeeds, we get n, and then we jump straight to the else, and we get n squared is 16.0, and then we return it. But when we get Dan, we don't get a value for n, we instead jump to the except, we get n equals 0, we don't run the else because the else only runs if we succeed in the try.
We jump to finally where we return n squared, but n squared was defined here, so we get an error. The answer here will be 16.0 and error. Now it gets a bit more complicated. We've got the user input as the user's what the user types. Then n is a float of user input. If we fail to get the user input, we return 0. And finally, at the very end, we get n squared is n to the power of 2, and then we return n squared. So this is a tricky question. It's a trick question, in fact, because you see the return 0 here, and you think, hey, we are going to return 0 in the accept, right? But that's not really what happens. So what we're going to see is we're going to run through the try with the input 4. That's going to give us 16.0. And then we're going to jump right to the finally. 4. And then we're going to do 4 to the power of 2. It's going to give us 16.0. We're going to return 16.0. All is good. So for now, we've got one of these things. The first return is going to be 16.0. But the second one with Dan, what you may think is, float of Dan is going to give you an error. So you're going to jump right into the accept, and you're going to return 0. So a pretty reasonable thing to think would be the C, would be the answer. 16.0 and 0. Notice how it can never be 16.0 and 0.0, because here we're returning 0, not 0.0. But actually what happens is a pretty interesting thing in Python. If you return inside an accept, and then you return inside the finally takes precedence. So this will return. And so what you're going to get instead is 16.0 and error, because n squared does not exist. So the finally is always going to run if you have a return in it. If you don't have a return in the finally, the code would work, but it wouldn't return 16.0 at first. It would return none. But this return 0 would work. You would not try to run this line, which is a bit of a bizarre thing. Just something to remember. If you have a return in the finally will always run no matter what you do in the accept. Okay, so the answer will be 16.0 and error. And that's it. And it says here, the finally block will get executed regardless of the return statement in both a try block and an accept block. Okay, so there you have it. And you have the results, and you'll be able to see a couple of lectures that you can check out if you did get any wrong in there. Now, if we go over back to Pycharm, we see that we've got here their latest answer. Power of 2, ask the user for an input, and then we try to turn it into a float. And we can try this out indeed with the inputs that they typed. So we can do power of 2 and then power of 2. Again, we can run this app and see what happens. We're going to enter 4 at first. And of course, we're not printing anything. So we're going to stop this and make it print. There. Let's run this again. First thing, we're going to enter 4, we get 16.0, then we're going to enter Dan, and notice how it doesn't quite work, because the finally there is being executed. This thing here is saying n squared is n to the power of 2, which means we did not exit the function in this return. Okay. Now, the way to implement something like this is, if possible, and really the way you want to do try, accept, and finally is, everything you want to try, put it in the try. So in this case, what we want to try is to deal with user input. So what you would want to do is you would want to put this in here and get rid of the finally entirely, because the finally is used to do something at the closing of a block. And here we don't really have a closing of a block. We've got things we want to try. And if we don't succeed to get user input, or we don't succeed to multiply it, to square it, then we don't want to do anything. Potentially, we want to return 0. So that may be what you want to do in your function. So this would now work. If you enter 4, you get 16.0. If you enter Dan, you get your input was invalid using default value 0, and you get 0. Okay. So again, the thing to take away from this is two things, in fact. The first one, it's really easy to become close-minded when you're dealing with a problem for a long time and sort of lose sight of the big picture. It's a common thing to do. What you can do is you can go and grab a cup of coffee or go for a nap and then come back to it and it'll be simpler. Or, of course, you can ask a question in the course Q&A. We very frequently find student questions that are, things that you can spot after you've not looked at something for a few hours. For example, like a comma there or something like that. If you put a comma at the end of here and you've been working on this for many hours, it may not even cross your mind that this can cause a problem. So if you've been working on something for a long time, sometimes that can cause narrow focus and it can cause that you don't see the big picture and you start just thinking about what is the one line of code I can add to make this work? And you stop thinking of how do I think of the problem in a different way entirely so that the solution is simpler. And the second thing to take away from it is put everything you want to try in the try block. Everything that depends on one another, just put them in the same block because that's going to make your life much simpler. And then any problem that can result from this code will be caught by this value error here. And if necessary, if there are multiple problems that can result out of trying this, as you know, you can just chain errors here, like runtime error or something. You can chain these here so that the error gets caught no matter what. In the unlikely event that you want to use a finally or an else block, just remember, the else block only runs when you succeed, and the finally should be used to close down something. So don't use them indiscriminately because that's going to bring you problems like it did for Dan and Ben. That's it for this video. Hope you've enjoyed it, and I'll see you on the next one.
Hi and welcome back. In this video we're talking about debugging, particularly using the Pycharm debugger. The term debugging actually comes from one of the first computers that was built. Computers back in the days were massive behemoths taking up entire rooms, and their cabling was actually just exposed. And it turns out that a moth flew into one of the cables and some of the transistors there, and it caused the short circuit. And hence the term debugging was coined. It is actually removing bugs from the cables, or in our case from the code, so that our programs don't crash and don't perform badly. So we're going to try to remove any bugs from, say, our program here. And let's imagine that our bug is that we have misspelled this metrics click, and it should be clicks, because that's what the data is like. So let's imagine we don't know that, and we're trying to find out what this problem could be like, or what this bug could be caused by. Naturally, we have a nice exception handling here, but as you can see, we've not re-raised the exception, so all we're going to see is incorrect values provided. We're going to look through our code and so forth, and we're not going to find anything, so we eventually reach the point where we have to debug. To debug, what to do is to make sure that the correct file is selected, right-click it, and press debug. Now, debugging is just going to run your application, your file, as normal. So right now, if we right-click and debug, it's going to load up. It's going to be a bit slower than just running the application because there's a few more things happening in the background, and then we're going to see incorrect values provided to our calculation function. Because, of course, we got that key error caused by the incorrect key being used there. Now, if we weren't able to realize that this is misspelled, we might decide to set a breakpoint. A breakpoint allows our program to stop at any point, and we can check values of things and we can run functions and see what breaks. So this error here is raised by the perform calculation function. We know that because it's the only thing that's running in this line. So we know that this is the thing that must be causing the error. Otherwise, it would not be caught by this key error here, exception. So we can set a breakpoint, and in order to do that, just go over to the left here beside line 13 and just click it. Then a red circle will appear, the line will go red, and this tells you that you've set a breakpoint on line 13. Let's run the debugger again. You can either right-click and press debug user score, or now that this has just recently ran, you can press the wee bug icon here, or of course you can go to the top right and press the bug icon. Make sure that the right thing is selected, user score, in order to do that. Now we can see that our program has stopped. And it stopped here at the breakpoint. The line is now blue. That tells us this is the current line that we're running. The line has not ran yet. So we have stopped just before the line. The breakpoints will always stop just before the line. We can see that our user parameter here has a value of user Rolf. We cannot select this text here. Think of it as some floating info. It just tells you what the value of the variables in scope currently are. It's really handy. And notice how this uses that repr function. Earlier on when we talked about repr and str functions, I told you the repr function was most useful for development purposes. And this is why. Because whenever you see a variable, Pycharm is going to show you the repr of that variable when it's telling you the values of it. Now, if you open the debugger tab here on the left, which may be open by default, you'll see a bunch of stuff, and it can be pretty scary the first time you see it. The most important part here is these variables and these buttons up here. The variables once again tell you what variables you've currently got in scope. Inside this function, we only have one variable, that's the user parameter. Here, you can also open it up using this triangle. And then it tells you all the properties of the user at this point in time, currently, before we've executed this function here. Remember, this function is meant to update the user's score, but it's not ran yet, so it's still 0, as it should be from the init method that was called earlier on. You've also got the engagement metrics, which is a dictionary. You can open that, and it tells you the clicks key and the hits key and the values. And you can also open up the name and you can see that it's Rolf. You get a lot of information from these things, including their types, dict, int, str, the length of the dictionary, and you get these numbers here that you don't have to worry about for now. So we now know that on running this function, an error is going to happen. We know that because this error was being caught on this line, and that's the only function that's running. So there are a few things we can do. The first thing I would do when encountering this thing here is to use the calculator. This is the expression evaluator, and what that's used for is running any arbitrary Python code. We're going to select the entire thing after the equal sign, that's perform calculation, including user.engagement metrics. Just select it. Don't need to copy it or anything, and then press the calculator icon. Now you've got the expression evaluator, and it's pasted in the thing that you've just selected. So that's perform calculation with user.engagement metrics as the argument. You can run this code. Let's press evaluate. And notice how now we get this key error click. That's pretty cool. The console, which is by the way behind here on this console tab, does not show anything. It doesn't catch the error or anything like that because this is a completely separate runtime, if you wish. So this is not running our program. This is just running this function here completely separately using the data that you've got in your scope. That's why you can use the user variable here. And we get a key error, which is click. So now we've got a bit more information. We know that the click property is incorrect. Okay, let's say that doesn't tell us enough information, and we want to stop here inside this line just to look at what the metrics object is. Well, there are two ways you can do that. You can set a breakpoint in that line, and remember the breakpoint is going to make you stop right before the line executes, so the error won't have happened yet when you stop at this breakpoint. And if you set a breakpoint there, you can press continue resume program execution. That's this icon over here, the play icon. You can press that, and that's just going to continue your program until the next breakpoint, or until it terminates if you don't have a breakpoint. So you can set a breakpoint and press continue. Another option is for us to use these buttons here. These are really useful. The first one here steps over to the next line in the file. So what's the next line after this one? Not the next line that will run, but the next line in this scope. The next line will be this print, because the exception is going to be raised by this function here, this line. So when we raise the exception, we're going to go into the except. I'll show you exactly what happens. See, we go into the except, nothing happens here, of course, and then we can step over again, and now we are inside the except block. Step over moves on to the next line in the current scope, in the current block. So it'll just go over into the next one. If you're within a function, it'll stay within that function. If you are in a class, it'll stay within that class, and so forth. Now, we are already too late. The error has already happened, so we're no longer going to be able to go back here. If we now set a breakpoint inside this line and we press continue, we already passed that. So what we're going to do is this breakpoint here is going to get ignored, and we're just going to resume the program execution until the end. Let's press continue now. And as you can see, the program continues, the blue lines disappear, and the console now has this little small yellow arrow there that tells you that, hey, new console output has happened since you last saw this tab. When you click on it, it disappears, and now you can see the output of your program. Incorrect values provided to our calculation function. Nothing new there. I'm going to remove the breakpoint on line 22 and run the program again, debug the program again. And once again, we will stop at our original breakpoint in line 13. Except now we're going to go into step into. Step into takes us into the function that we're running in that line. If we're running multiple functions, it'll take us into the first function that runs on that line. But here we're only running one function, so step into takes us into the function, and now this line is blue. This is the line we're currently running. Notice how now the metrics parameter here, we also get the contents of it. Clicks is 61 and hits is 100. For me, this is as far as I would have to go, of course, before noticing that clicks and click are completely different strings. There's an S missing there. And so then you would just change this to an S, and you would rerun the program. Change it to an S. Notice how now that disappears because we've made a change, and you can just rerun the program by pressing this button here on the left. Now we are back at our perform calculation breakpoint. We can step over in order to move over to the next line, and now we know that we should move into the else line. And that's what happens indeed. Because there's nothing there on the else, it just moves on to the next line that actually does something, which is this if. Now here we've got the user.score, which was set by this line above. If we open up user, we can see that the score is 505. So my 502 earlier on was completely wrong. It's 505, but it is greater than 500. So once again, we can step over, and that will take us into the next line in this function, which is send engagement notification. Now that we're here, we know that we are going to send the engagement notification, because this is the function that's about to run. If you want, you can step into, and that takes you into the send engagement notification function. Potentially, if this was doing something more interesting, you could, of course, have a look at it. And if you want, you can select this F string entirely. You can run the calculator and evaluate it and see what it's going to give you. This is totally fine, and a lot of the development is happening on the debugger when I'm at work. You're constantly sort of debugging and making small changes, running the calculator to see exactly what do I want to include in this function. Once you figure it out with the calculator, just put it in. And that simplifies development quite a bit. And by the way, this button here, step out, takes you to whatever function called you, where you are right now. So if you step out, now you are here, but this function has already ran, so that's important. Now, in this line, you are after the function, not before it. So if you were to step over, now you would exit the function entirely. And you go back to right after the function that you called, which brought you into there. I'm going to remove this breakpoint, by the way. So now we are after this function. If we press step over, we're going to end the program. And as you can see, all the blue lines disappear. And now we see in the console the notification that was sent to our user. So once again, I'm just going to debug the program with the breakpoint to give you an overview of what we've seen. And what we've seen is that we can set breakpoints, and that causes a program to stop when we are in debug mode, not when we are in normal play mode. If you are in normal play mode, breakpoints are going to be ignored. So you can set a breakpoint by clicking on the line, and that's going to stop your program there. You've got access to all of the variables in the current scope, and Pycharm is nice enough to give you their values there, but you can also see them down here in the variables tab. And you can open them up and you can have a look at them and so forth. You've got the calculator icon on which you can run any arbitrary Python function you want. Or indeed, you can just look at values of things, like you can type user and that's going to give you the user values. And you can also modify values if you want. You can say user.score equals 200. This returns none, but now you can see down here in your variable that your user variable now has a score of 200. And it's blue to tell you it's just changed between now and the last time you pressed one of these buttons. Down here you've got your threads, and I wouldn't worry too much about this. It's just the trace of where you've been. So you entered this function in here. This is the function that called the function you're currently in. And this here is the function that called your file. This here is the function that called your file, and so forth. So as you can see, Python here, these with a yellow background, by the way, are the ones that you didn't write. These are Python. And there's something here about setting up a debugger and running it and so forth. Nothing you have to worry about, but nonetheless, these things are what called your file originally. You'll normally be interested only on the ones with a white background. That's these two. This is the first line that ran in your program, related to where you are now. And this is the second line, the one where you are now. Of course, we've looked at restarting, continuing, which goes on to the next breakpoint if there is one, or until the program finishes. You can, of course, stop, and that just terminates your program. And you can step over, which goes on to the next line in this function. You can step into, which goes into the next function that runs, in this case, perform calculation. And you can step out, and that brings you from a function out into the function that called you, or right after it. There's a few more buttons there. Feel free to experiment with them. There's nothing that you have to worry too much about. Those are really the main ones. And when you're debugging, make sure to go slowly. Set breakpoints. Look at values. Run functions to make sure that they are doing what you expect. And that way, you're going to be able to deal with errors and any problems in your programs really, really easily. Most of the time is spent debugging. So just remember that. Don't treat this as a sort of secondary thing that you only do when you're in trouble. Use it and love it. And I promise it will pay off. So that's it for this video. I just wanted to show you how to debug using Pycharm. So I'll see you on the next one.